Hello and welcome. My name is S. Muhammad Zamin. I did my final year project in Larsen and Toubro, Kanchipuram. My work is based on experimental investigation on sustainable concrete incorporated with cactus gel and nano-silica. I was formally guided by Dr. S. Yuvraj, Associate Professor, Veltech University. My experiment gives an overview of the incorporation of waste materials for expensive and environment effective materials. As we know that the cement production is largely required, expensive and produces environmental issues. Also fly ash being produced gives the dumping issue. Hence these issues can be overcome with the idea of incorporating F-class fly ash in the concrete. The use of the cactus natural polymer substance as a water reducing agent will improve the workability of concrete and thereby deviating the strength that can be regained by adding nano-silica. With the incorporation of these materials, a cylinder, a cube can be designed, thereby giving a good. Recently, nanoparticles have been gaining increasing attention and have been applied in many fields to fabricated new materials with novel function due to their unique physical and chemical properties. In this experiment, the influence of nano-silica particles on the mechanical properties has been studied through measurement of compressive and tensile strength. The objectives that I intended to study were on these: to study the strength of concrete which were made by partially replacing of cement with fly ash and find out the optimum replacement percentage of fly ash to the weight of cement. Also to determine the proportions of replacing of cement with fly ash with addition of nano-silica at a rate of 2.5% to the weight of cement are done and their results are studied. To compare the analysis of strength of partially replaced fly ash concrete with the nano-concrete. Also to study the split tensile strength and the compressive strength of concrete. The literature review that I studied were on these: influence of cactus mucilage and marine brown algae extract on the compressive strength and durability of concrete, which was studied in 2016. The second one is on application of nano-silica in concrete mixtures, and it was studied in 2015. Third one is an investigation of nano-silica in the cement hydration process. It was studied in 2015. Influence of nano-silica particles on mechanical properties and permeability of concrete. It was studied in 2010. Influence of amorphous colloidal silica on the properties of self-compacting concretes. It was studied in 2002. The methodology that I followed for the production of my process are these. Firstly, I did literature survey, followed by study of materials, and then testing of materials. Then I did mixed design, which were on both conventional mixed design as well as mixed design for the partial replacement, followed by casting of specimen and then tests on specimen, then did the comparative study, found the results and discussion, followed by conclusion. The materials requirements were these for my project: cement of grade 53 as a binder, sand as fine aggregate, recycled aggregate of 20 mm, nano-silica as an admixture, cactus gel also as an organic admixture, and water. Here is an example of coarse aggregate that I used. It was retained on 20 mm sieve. This is an example of nano-silica. The nano-silica is arrived from grinding the highly silica content sand in the ball mill apparatus continuously for 40 hours, and the particle size of the nano-silica is as follows. The range of the size were between 35 nanometer to 46 nanometer. Average size were found to be 41 nanometer, whereas the diameter of nano-silica was 42 nanometer. The image shows an example of nano-silica. Here is an example of cement and fly ash. A cement of PPC 53 grade and a fly ash of F class. An example of cactus and cactus jelly. I collected cactus from the local area, took out the thorns and crushed it, and then kept in water for 7 days until it became a jelly solution, which could be made as water and addition in the concrete. The tests on materials that I followed on the cement were fineness test, standard consistency test, setting time test. On fine aggregate were as follows: sieve analysis and zoning, specific gravity test, moisture content test. On coarse aggregate, sieve analysis, specific gravity test, moisture content test. Fineness test on cement was found to be 5%. Standard consistency test on cement was found to be 32%. It was completely followed codal provisions as per IS 5513 1968, where standard consistency of cement depends on the type of cement. Figure 11 shows wicket apparatus. Initial setting time test on cement. Quantity of cement was 400 gram. Water found out to be 98.6 ml. Initial setting time found to be 54 minutes. Final setting time was found to be 10 hours. Codal provision was followed as per IS 12269 1987. Initial setting time is not less than 30 minutes and final setting time is not more than 10 hours. Specific gravity test on river sand was found to be 2.53 as an average. Specific gravity test on crushed sand was found to be 2.59 with 2 trials. Specific gravity test on coarse aggregate was found to be 2.63 as an average. Water absorption test on coarse aggregate was found to be 2.50 as an average with 2 trials. According to IS code 2386 part 3, maximum water absorption percent for recycled aggregate should lie between the 6% to 7%. Mixed design has a grade of M50, cube of volume 0.003375, cylinder of volume 0.00157 per meter cube. For model 1, material required for cement was 15.334 kg, water was 6.899 liters, coarse aggregate was 33.55 kg, fine aggregate was found to be 26.51 kg. For model 2, which was based on completely waste materials and 60% of fly ash, the material required cement was totally 6.746, fly ash 10.12, river sand 14.628, crushed sand 9.928, coarse aggregate of 20 mm 30.84, water 6.90 liters. For model 3, cement came out to be 6.746, fly ash 10.12, river sand 14.626, M sand 9.982, coarse aggregate of 20 mm 30.84, water 5.865, cactus gel 10% 0.174. Casting and curing. Figure 25 shows an example of mixer. Figure 26 shows an example of mixing the concrete along with nano-silica. Figure 27 shows an example of casting the cubes and cylinders. Figure 28 shows an example of curing with bonding method. Results of compressive strength of cubes. The specification for cubes are as follows. C1, C2, C3 being the conventional design, R1, R2, R3 being the design of concrete with 60% of fly ash and waste materials. N1, N2, N3 represents concrete with 60% of fly ash, waste materials along with cactus gel and nano-silica. The testing was done between 7, 14 and 28 days, and the compressive strength in terms of megapascal are observed. Figure 29 shows an example of compressive strength testing. The graph of compressive strength was plotted. The specimen C represents conventional design, which was found out to be 58.9 megapascal. The specimen R shows an example of the concrete with 60% of fly ash and waste materials, which found out to be 25.5 megapascal. The specimen N represents the concrete with waste materials, 60% of fly ash, as well as nano-silica and cactus gel, which was found out to be 43.98 megapascal. The split tensile strength of cylinder was tested with the specification of C1, C2, C3 being the conventional design, R1, R2, R3 being the concrete with 60% of fly ash and waste materials, whereas N1, N2 and N3 represents the concrete with waste materials, 60% of fly ash and with nano-silica and cactus gel. The testing was done as usually 7, 14 and 28 days, and the split tensile strength was recorded in terms of MPa. Figure 31 shows an example of split tensile strength testing. Figure 32 shows an example of split tensile strength. The specimen C, being the conventional design, found out to be maximum, whereas specimen R, being the concrete with waste materials and 60% of fly ash, was found out to be 1.51, which is the least. The specimen N, the concrete with waste materials, 60% of fly ash and with cactus gel and nano-silica, was found out to be 80% better than the waste materials concrete, which was found out to be 3.16 megapascal. These are the references that I followed on study. Thank you.